Okay, so lecture 7, divergence theorem, part 2. So let us recall what is divergence theorem. Okay, so let G be a solid whose surface sigma is oriented outward if f of xyz equal to f of xyz I plus g of xyz j plus h of xyz k, where f, g, and h have continuous partial derivatives on some open set containing g. If n is the outward unit normal, that means then double integral over sigma f dot n ds is equal to triple integral over g div f dv. So this is the formula of divergence theorem. Double integral over sigma f dot n ds is equal to triple integral over g div f dv. Okay. Now I will define what is sources and sinks. So in an incompressible fluid, the points at which divergence of f at P naught, the P naught is a point, right? P naught greater than 0. That means divergence at a point greater than 0 are called sources. So the sources are the points at which divergence are greater than divergence at that point greater than 0. And the points at which divergence of f at P naught less than 0 are called sinks. So if divergence is greater than 0 at a point, then at that point there is source, and less than 0, then there is sink. If divergence of f at a point P naught is equal to 0, these points are called or without sink or source, or free of sink or source. Now let us define an example. I will give you an example. Example for source. Source, for example, it's condensation. That means, in a surface, the fluid is entering the flow. Fluid is entering the flow. Example is condensation. That is source, entering the flow. Or, for example, melting of an ice cube is a example for source. So that is the real life examples. And sink is example evaporation, that is fluid is leaving the flow. So from one surface the fluid is leaving, then we say that it's a sink. So in order to find out source sink, we have to find out divergence at a point. Now we will do a problem. Determine whether the vector field is free of source and sink. If not, it is not, locate them. So first question, we have to check whether f of x y z equal to y plus z I minus x z cube j plus x square y k is whether there is a source or sink. If there is source or sink, we have to find that point. Okay. Now, so given solution, so we have to find whether there is source or sink. So first, given f of x y z is equal to y plus z I minus x z cube j plus x square say 1. Now tell me what is divergence of f. First we will find divergence of f. Okay, tell me what is divergence of f. Anybody? This is y
0.
0, right? 0 I, and here minus xz cube. Its derivative with respect to y is 0, and this is also 0. So which implies divergence of f is 0 for all points. So here x, y, z. If you take any point, divergence will be 0. Therefore, we say that f is free of source sensing. Okay. So there is no point of source, no point of sink. Only all points are free from source sensing. Okay. Now we will do another problem. Now tell me what is divergence of this f of x, y, z is x cube I plus y cube j plus z cube k. Divergence is 3x square I. Sorry, 3. Sorry, here I am. There is no I. 3x square plus 3y 3y square plus 3z square, because divergence is a scalar quantity. So there is no vector quantity. So this is 0. Okay, so this is equal to 3 into x square plus y square plus z square. Now tell me what are the points of source and sink. For what value this is a source? When this is greater than 0. 3x square plus y square plus z square is always greater than 0, right? If you put any value x, y, z, that means if you put minus 1, 2, 3, then x equal to minus 1, then minus 1 square, 2 square plus 3 square. This is always positive, right? Any value, if you take any value, here it is all square terms. So this is positive for all values except except at 0, 0, 0. So except at 0, 0, 0, all values divergence of f is greater than 0. Therefore, f is source when for all points except at 0, 0, 0. Okay. And at 0, 0, 0, what is that is free of source and sink. So at 0, 0, 0, that means if x0, y0, z0, it is a divergence of f is 0. Therefore, it is at 0, 0, 0, it is free from source and sink. And for any other value x, y, z, it is a source. Okay. Have you got it? Anybody have any doubt? So what we have to do is we have to find the divergence and we have to check which points f has divergence is positive or negative or 0. So if it is positive, the points at which f is div f is positive, that points are called source, and the points at which div f is negative is called sink, and equal to 0 it's called free of source and sink. So we can easily find a source and sink by using divergence. Okay. If you have any doubt, you can ask me. So this is a now we will move to problems. So we will do few problems from divergence theorem. Uh, I think it is comparatively easier. Use divergence theorem to find the flux of F across the surface sigma with outward orientation. So f of x, y, z is given x square plus y I plus z square j plus e raised to y minus z k. And sigma is a surface of the rectangular solid bounded by the coordinate planes. What do you mean by coordinate planes? Anybody? What do you mean by coordinate planes? This is x equal to 0 plane, y equal to 0 plane, z equal to 0 plane. So these planes are called coordinate planes. Okay. So it is bounded by coordinate plane x equal to 0, y equal to 0 and z equal to 0, and also by the plane x equal to 3, y equal to 1, z equal to 2. So now we have to find out the flux. So we know that by divergence theorem, what is double integral over sigma fn dot ds? Divergence theorem is triple integral over g. What is this? Double integral over sigma f dot and ds is equal to triple integral over g
Divergent of F.
divergent of f dv. Okay. Now first we will find the divergent of f. So I will write we have f is equal to x square plus y I plus z square j plus e raised to y minus z k. Now tell me what is divergence of f?
2x
2x
plus 0
plus 0 minus 1, right? E raised to y minus. So that is equal to 2x minus 1. I got it. Now we will find double integral over or triple integral over v div f dv. This is actually equal to the flux by divergence theorem. Double integral over v 2x minus 1 dv. Now we have to find the limits. Okay. So first, so this is our x, y, z. So this is actually a rectangular box. So it is bounded by x equal to 0 plane, y equal to 0 plane. I will draw once again. So this is actually a rectangular box. So it is already bounded by these coordinate planes and also bounded by the plane x equal to 3, y equal to 1, z equal to 2. So something like a box. So this is z equal to 2 and this is z equal to 0. XY plane is z equal. So what is the range of z? Z ranges from y ranges from and x ranges from. So this is actually a rectangular box. Then what are the limits of z? The upper surface is definitely z equal to 0, right? Sorry, lower surface is definitely z equal to 0. 0 to what is upper surface?
2
2.
2
Similarly, x and y ranges from 0 to 1 and x ranges from 0 to 3. Now we can write this integral as triple integral over. First we will write limit of z 0 to 1, 0 to 3, 2x minus 1, dz dy dx. So this is equal to Okay, this is equal to integral 0 to 3, integral 0 to 1, 2x minus 1 dz. If I put a limit, you will get 2 into 2x minus 1. And if you integrate this, you will get, say, and dy dz. So the answer will be equal to 12 if you calculate this. So this is simple integration. So if you calculate this, answer will be 12. Okay, you can check whether answer is 12 or not. Okay, is it clear? So what we have to do is we have to find out divergence of f, and then we have to find the region of integration. So here, so only this rectangular box, so we can easily find the limit and integration. So now we will do one more problem. So we want um, by using divergence theorem, we have to calculate the flux of this x square plus yi plus xyj minus 2xz plus yk is and sigma is the surface of a tetrahedron in the first octet bounded by x plus y plus z equal to 1 and the coordinate planes. So tell me, what is coordinate plane?
X
Coordinate
is equal to 0.
equal to 0 plane, y equal to 0 plane, and z equal to 0 plane. And also it is bounded by the surface x plus y plus z equal to 1. So now first what we have to do is, I will write what is f. F is x square y plus y I plus xyj minus 2xz plus yk. Okay. So next we will find the divergence of f. Tell me, what is divergence?
2x 2x
Plus
plus 1
it
x
x, right? Xy
x
x minus, what is this? 2xz plus,
2x
that is 2x. So this 2x and this 2x get cancelled, and the answer is x. So divergence is x. Now we know that by divergence theorem, f dot n ds is equal to triple integral over v div f dv. So now what we will do is we will find this triple integral over v. Divergence of f is x dv. Now next we have to find out the limit of integration. So I just draw what is x, y, z, and this x plus y plus z is a plane equal to 1 that is cut by coordinate planes, right? X equal to 0. So here 1 0 0 0 1 0 0 0 1. So these are the intersecting points, right? When x equal to x and y equal to 0, z equal to 1, z and y equal to 0, x equal to 1. Okay. So our surface is something like this. So this is the surface. So this is actually z equal to uh, or x plus y plus z equal to 1, or we can write z equal to 1 minus x minus y, and it is bound. Okay, now we want to integrate it. So what is limit of z? First we will write limits of z. So from where to where z ranges? So while integrating triple integral, first we will find the limit of z. So that means upper surface and lower surface. Here what is lower surface?
0.
Z equal to 0. Okay, 0. And what is upper surface?
1.
Is it 1 or this surface? Upper surface.
Uh,
1 means you will get a like what? If it is 1, then we will not get this. We will get it like this. Right? But it's a plane. So that will be the surface is actually this, right? Surface is given x plus y plus z equal to 1. So what is z? 1 minus x minus y. Have you got it? So that is the upper surface, and lower surface is z equal to 0. Okay, so this is the upper surface, and lower surface is coordinate plane z equal to 0. And first we will integrate this double integral over. Now we want x and in image of x, limit of x and y, we have to find the projection r. So r, first I will do integral with respect to z. So 0 to 1 minus x minus y x dz dA. So first we will integrate this double integral over r xz x into z dz 0 to 1 minus x minus y dA. So this is equal to, okay, so this is equal to, I will write here, double integral over r x into 1 minus x minus y dA. Now we want to find out the limit of r. That means the projection of this on the plane. So in order to find the projection in the plane, we already have it is cut by x equal to 0 and x equal to y equal to 0. So we have in xy plane, it is cut by x equal to 0, y equal to 0, that is this line, x equal to 0, this line, and also we have the surface x plus y plus z equal to 1. So in order to get its projection, what we will do? We will put z equal to 0. So if I put z equal to 0, I will get this bounded by x equal to 0, y equal to 0, and x plus y equal to 1. X plus y equal to 1. Okay. Have you got it? And this what you have studied in your first semester. How to evaluate triple integral. Okay. So what we will do is, in order to evaluate triple integral, first we will find the upper surface and lower surface in terms of z. Can we integrate? Then we will find the projection of the surface in the plane, and then so here this is 0. Okay. So therefore we have to integrate double integral over r x into 1 minus x minus y dA is equal to, okay, this is our r. Now we have to find out limit of r. So tell me, if I am taking horizontal vertical strip, so what are the limit of x and y? Anybody? This
X is equal to 0 to 1.
0 to 1. Good. And y ranges from
0 to 1 minus x.
0 to 1 minus x. Okay. It's clear. So similarly, what we done here? Here also z equal to 0 is the lower surface, and z equal to 1 minus x minus y is the upper surface. So we get it, right? So now therefore double integral over r x into x minus x square minus xy. If you multiply this, dA is equal to integral over 0 to 1, integral over 0 to 1 minus y, sorry, 1 minus x minus x square minus xy dy dx. So now we will integrate 0 to 1. Okay. If I integrate xy minus x square y minus x y square by 0 to 1 minus t. So this is equal to, I am writing here, the integral over 0 to 1. I put x into 1 minus 5. Sorry, I have made a mistake. 1 minus x, right? Limit is 1 minus x. Now it's correct, right? Limit is 1 minus x. X into 1 minus x minus x square into 1 minus x minus x into 1 minus x all square by 2. So this is equal to integral over 0 to 1 x minus x square minus x square plus x cube minus x into 1 x by 2 into 1 minus 2x minus plus x square. So 1 minus x all square is this. You can also integrate without simplifying. Okay, 0 to 1 x minus x square. So you can write x minus 2x square plus x cube minus x by 2 minus minus plus x minus x cube by 2. So this is the integral of 0 to 1 x and minus x by 2. So that is x by 2 x is here minus, now minus 2x square is a mistake x minus 2x square plus x cube minus 2x square plus x cube minus x by 2 minus x by 2 plus x square, right? Here x square is there. Minus 2 and 2 get cancel x square. So minus 2x square plus x square is minus x square. X cube minus 3x cube by 2 is plus x cube by 2 dx. Now I will do integral. I will insert slide. So this is integral 0 to 1 x by 2 minus x square minus x square by 2 plus x cube by 2. Okay. So if you integrate this, x square by 2 minus x cube by 6 plus x raised to 4 by 8, 0 to 1. So this is 1 by 2 minus 1 by 6 plus 1 by 8. So if you add this, you will get so 6. I can take LCM of 6. 6 plus 1 by 8. 2 by 6 plus 1 by 8 is equal to 17 by 6 into 8, 48. So this will be the answer.